Rise and ground, folks. Guys, I am on the way to an existing maintenance customer. This is a heat maintenance. I believe this customer has an air handler and heat pump, relatively new. We came out here this past spring, I believe, for the AC maintenance. Everything is rocking and rolling. Nothing got replaced, obviously, because it's brand new. But guys, I am almost here right now. Let's go take a look. I'll see y'all when I get inside. All right, guys, this is a Carrier heat pump. Let me try to zoom in here so y'all can see. Year is 2024, so it's about 2 years old. 2.5 ton. This is a 30. And this is a pretty tight space here. I don't think we checked the cap last summer. I just killed the disconnect. I'm gonna check the cap. Electrical component area looks good. All right, guys, let me get my meter. I'll be right back. All right, guys, we got our 35-5 cap. And remember, like I mentioned in previous videos, even with newer heat pumps, this capacitor gets used year round since this heat pump does the heat and AC. So guys, even if I told you before that within 3 years, you're not gonna have much wear and tear on most typical dual caps, that could vary with heat pump capacitors, being that this is a 2024 model. It wouldn't surprise me if the numbers were a little lower than normal, since this is a year-round item to be used. But out of a 35, let's see what we got. And like I said, we didn't check this past spring. 34.85, that's not bad. But guys, another thing I want to go over, I seen this in a forum like maybe 5-6 years ago. One thing I never got the chance to try before, and you guys see this here. This is my four-way valve, or my reversing valve. I only seen one stuck reversing valve in my brief 11-year, going on 12-year HVAC career. One thing I seen on the forum, there was a service tech that had a no heat call on the Carrier heat pump, similar to this one. And what the tech said was he used a magnet to unstick the four-way valve. Guys, that's something I have to verify for myself. Even if the four-way valve sticks and you're able to unstick it, would you still trust it? That is subjective. That's up to you. That's up to your company's policies. If the four-way valve sticks for no apparent reason and you're able to unstick it, that would immediately raise red flags to me, guys. But the guy said he was able to use a magnet and unstick it. That's pretty cool if you can pull it off. I only seen one of those before. And guys, what I tried to do is, this is before, you know, I seen this forum. This had to be at least 10 years ago. What I did was I had a no heat call. I think it was a Carrier O'Brien heat pump, and the four-way valve was sticking, meaning if you turn your thermostat to heat, your suction line is going to be ice cold, meaning this heat pump will run, but it's going to run in cool mode. So guys, what I did was I used my Monday morning quarterback routine. I made sure my wiring, inside in, outside, everything is copacetic. Everything matched up. And once I realized that my reversing valve was running in reverse, I turned it to AC and I turned it to heat, and I was able to unstick it that way. But this is back in 2012, 2011. Immediately, I told the customer to start saving up for a heat pump. I told her what I did. I don't know if this is going to be a permanent solution, flipping it to AC and then back to heat to unstick that reversing valve. But guys, let me know in the comments if you guys had stuck reversing valves, what methods you guys tried. But guys, this reversing valve is hermetic, meaning it's non-serviceable. So if any internal mechanism sticks inside reversing valves, there's really not much you can do. If you get lucky to unstick it, you know, kudos to you. But most of the time, I don't want to deal with the headaches of unsticking it now, and then I'm getting a call back at 2 o'clock in the morning that the heat pump is blowing out 40-degree air in the winter. So let me know what you guys think in the comments. I'm curious to see other stories of how you guys had to battle with these four-way valves. I never really had to unstick reversing valves without stepping back and realizing I'm dealing with a 50-year-old heat pump. But let me know what you guys think about that. But guys, what I'm gonna do is I am gonna put this capacitor back in, and I'm gonna check my defrost board. And also, by the way, I got my thermostat off. The house is already up to 72. By now, I know it probably would have been up to 75, 76 degrees. So I gotta put this back in, And once I turn the thermostat back on, I gotta wait for the time delay on the stat, and I gotta wait for the time delay on this defrost board. All right, guys, let's get to it. I'll be right back. And if you know, you know, there's a reason why the 24-volt terminal closest to the capacitor is insulated. Reason being, guys, with ICP, meaning carrier Bryant Payne, with their heat pumps, they like to put the capacitor screws within inches of your contactor coil. And guys, right now I got the power off inside, but if this thing was running, and once again, if this was 4 o'clock on a Friday, I'm trying to get in and out, if I'm not careful and I unscrew the capacitor and I put my nut driver too close to the contactor coil, instantly this will either kill my transformer or kill my fuse inside. So what the proactive engineers at Carrier did was they insulated the spade connection terminal, which helps, but it doesn't really help. That's only 1/3 of what can actually short out. We still got the terminal, we still got the coils right next to it. I would still recommend them moving the capacitor 5 inches over, but what do I know, guys? I'm just the guy that fixes this. Once again, I don't manufacture this stuff. I just like to complain. But anyway, guys, I got everything buttoned back together. I'm gonna flip my breaker or turn my disconnect on, and I gotta turn the power on, wait for my time delay, and I'm gonna check amps. I'll be right back. All right, guys. 0.53, 4.51, and this is a very precarious week in Pennsylvania. Listen to this, guys. I think right now, today's Monday, I think the temperatures by the end of this week is going to get back up in the 60s. We're still getting overnight temps in the mid to low 30s. Well, technically mid 30s. We're not getting below freezing, but we're getting overnight temps under 40 degrees. So no doubt about it. I know by now my defrost probably had to turn on in the middle of the night. And guys, I already got one call from a customer last week about this. He has about 4 or 5 heat pumps. The customer called me. He goes, yeah, I got a error code on my ecobee thermostat. It says that my auxiliary heat is running for an extended amount of time. And guys, with ecobee, that's one thing you need to acclimate yourselves with Wi-Fi thermostats. Wi-Fi thermostats are smart thermostats, so it measures runtime of your primary heat source, meaning your heat pump, and it measures the runtime of your auxiliary or your backup heat. This customer had a dual fuel setup. He had a gas furnace inside and he had a heat pump outside. But he called me about 2 weeks ago. That's right when the weather broke and we had like a 32-degree night for like 2 nights in a row. He called me, he was like, yeah, my heat is working fine, but I'm getting the alerts from my ecobee thermostat that my auxiliary heat is running for too long. I'm like, okay, wait a minute, let me look at the temperature overnight. And guys, as soon as I seen the temperature overnight in the 30s, I'm like, yep. Sure enough, I'm like, if the house is maintaining temperature, that's great. But I'm like, I told him the same thing I tell you guys. Heat pumps are great, but below a certain point, to prevent the coil from freezing and to prevent this heat pump from damaging itself, this heat pump needs to turn off on defrost. And if this heat pump turns off on defrost, whatever your backup heat is, whether it be electric, propane, gas, or oil, your backup heat will need to run to maintain the set point in the house. While this heat pump defrosts, it melts the ice on the coil. So that's what I had to explain to him. And like I said, guys, like I mentioned before, out of every 10 customers with heat pumps, at least 6 of them probably doesn't understand exactly what to expect when it gets real cold with heat pumps. That's just a common thing with heat pumps, guys, because one thing most customers already know, in the summertime, this is a regular straight AC condenser, but in the wintertime, noises, sounds, how a defrost sounds when it turns off, alerts on the ecobee thermostat. You know, most customers have Wi-Fi or smart thermostats, but just the small intricacies, guys, of, you know, what to expect when it gets real cold. It's easy to explain this in the summer, guys, when the customer is not using the heat pump for heating, but when it gets real cold, I always tell every customer with a heat pump system, it's going to take you at least a good year to figure out what to expect, to figure out your set points, to figure out what temperatures are comfortable for you, and also just to get fully acclimated with what's normal and what's not. Because I remember when we first started off, guys, I'm talking in business back in 2016, almost half of our customers had heat pumps and we used to come out like crazy. Customers used to say, hey, my heat pump outside is making a loud noise. I don't know if that's normal or not. And guys, most of this stuff, you don't even need tools to diagnose this. You can actually help customers out over the phone as long as you've already been there and like you're acclimated with the system that you have. I'm not saying just assume that nothing's going on, but if you already been there and the customer has any concerns about noise with heat pumps, just take your time and simplify heat pump operations. Once again, you're not talking to a customer like how you talk to a technician, but keep it as simple as possible and keep things on a need-to-know basis. They don't need to know about, you know, the defrost mechanism. The only thing they need to know is that this heat pump is not going to run constantly if it gets below a certain point outside. Capiche? But all right, guys, let me put my meter up. I'm going to get my screwdriver and let's test the defrost out. I'll be right back. All right, guys. Got my defrost engaged. Now I'm going to enjoy the brief hot air for 2.5 seconds. Now it's back cold. All right, guys, my defrost is active, and this is something I mentioned almost on every single heat pump heat maintenance video that I made. On every heat pump maintenance, regardless of the age, you always want to test your defrost board regardless of the age. If I force the defrost and the defrost didn't engage, at that point I would recommend replacing my defrost sensor and the board. Reason being, if the coil temperature gets below 35 or 32 degrees and the defrost doesn't engage, now instead of having 1 or 2 small ice spots on the coil, if the majority of this coil freezes up, it could stop your fan motor from working, and now you're going to have a burnt fan motor to replace on top of potentially damaging the coil and or the compressor. So guys, it's a lot that can happen on the heat pump if the defrost board fails. That's why you always have to be preventative and make sure you test these on every maintenance. It takes about 2 seconds. Take your time. If the defrost doesn't engage within a couple of seconds of you jumping out the pins, this is something that you need to bring up to the customer's attention about what could happen, even if, once again, the heat pump is still working. If that defrost doesn't fully engage, then this is going to spell a nightmare down the line. But all right, guys, let me put the door back on. I'll be right back. All right, guys, everything's rocking and rolling. And one thing I didn't mention is cleaning the coils. Coils are still clean. We checked that out this past spring. But yeah, guys, there you have it. Carrier heat pump maintenance. Everything is still rocking and rolling. I got to do the paperwork and I got to head to the next one. I will see y'all the next one. Peace.